Today I'll talk more about ASP programming, and we will see how the statements of C# are organized and what the syntax of the C# statements are. And then I'll show you two websites that we work with, and we actually create a web-based calculator as a part of the programming for this class, and I'll show you how to use if and conditional statements and also loop statements. And then next week we'll talk about organizing the code and object-oriented paradigm of C# and essentially object-oriented programming. Okay, so we saw the different types of variables in C# and how we can define them and use them. But essentially, to make any program or any programming language work and essentially program for a website using these programming languages, we need to essentially give the code statements that it can execute. And these codes statements will essentially be defined by the specific programming language's syntax. And these statements can range a wide, basically range of actions. For example, showing a button, sending an email, executing such and such a code, and when a button is clicked, and so forth. But simply executing these actions essentially isn't enough. So we would have to use, for example, in some cases, in certain situations, to decide the truth of a condition, and based on this condition, decide to perform some parts of the code or another part of the code. For example, if you have a e-commerce website and people are trying to buy, for example, more than a certain amount of, or spend more than a certain amount of money on your merchandise, you might want to give them a specific discount. Otherwise, if they just want to just purchase the standard rate, they wouldn't get the discount count. So this is important for our statements to be able to evaluate a condition or a set of conditions when we're writing programs in our websites. And if you have already, I presume you have already experience with programming languages, so all of these generalities apply to all programming languages. And today we want to see about the specific types of statements that C# gives us and enables us to perform these kinds of actions and statements. Also, another important part of your programming language is essentially the statements that allow you loop over a block of code so that you could run a certain amount or certain parts of your program more than once if you need to, instead of having to write that parts of the code more repeatedly. Also, in terms of loops, sometimes the number of the times that your loop would have to run is not predetermined, so therefore you would have to have access to programming statements that would allow you to deal with this non-determined or not previously determined situations. Finally, the final important set of statements is the operators. Operators essentially enable you to basically do something with your variables and values, or they enable you to operate on these variables. For example, you can use operators to add or subtract values, to concatenate or combine them, or to compare them with each other. And we will dig into these statements in the rest of this the slides, and I'll show you specifically about C# syntax and the statements that C# has. If you are familiar with C++ programming language, then you probably will already have known about this, but it would be good to refresh our memories. So the most important operators that you use, you can logically group them into 5 different categories, and these groups include the assignment operator, arithmetic operators, comparison operators, concatenation operators, and logical operators. And I'll discuss about them as we go on. But let's first focus on the assignment operator. The assignment operator is used to assign a value to a variable, and this value can come from many different sources. It could be a constant value like number 6, it could be coming from another variable, it could be the result of an expression, or the result of a function, or a method, and we will discuss those things a little later. But essentially it is the simplest form of operation that you can perform on your variables, and that is to assign a value to the variable. So if you had a variable called age, and let's say that it's an integer variable, you can define it or declare it as int age, and then this would be an empty variable. Or if you want to assign a number to it, if you know that, for example, the age of a person is 23 years, you just define it, and at the same time you can use the assignment operator, which is an equal sign in C#, and assign value 23 to the variable age. And this is the way that this assignment is performed. Another type of operators, as I said, the second category is called arithmetic operators. And the arithmetic operators enable you to perform most of the familiar calculations on variables and values. Like, for example, adding two variables or two values, or a variable and a value. You can subtract them, you can divide them, you can multiply them. In this table, I have put the 5 types of arithmetic operators that C# supports, and to the left column, and the right column shows you the usage of these values. Now, at the top row where it says C# and usage, you see that I gave an example. And the example is essentially you have two variables, an integer variable called first, and its value is 100, and a float variable called second, and its value is assigned at 23.5. And another variable that is a double variable, and it is called result. So these variables are declared, and I would like to show you how these operators work for those who would like to remember the arithmetic operators in C++ and C#. So the addition operation, or the addition operator, is a plus sign, and it adds two values to each other. And the thing to notice is that they could be both values or numbers, or they could also be strings. In case of numbers, their numeric values is going to be added together. If they are strings, then they will be concatenated, meaning that the second string will be added at the end, or appended at the end of the first variable. So, for example, if you add the two variables first and second, your result will be essentially 123.5, and the first row next to the addition sign shows you the example. That is essentially you use the assignment operator, and you assign first plus second to the result, and the result will be 123.5. In the subtraction, you essentially can use a minus sign, and it subtracts one value from another. For example, if you type in result equals first minus second, the result will be 76.5. Multiplication essentially multiplies two values. It's a star sign, so you can multiply first and second, and the result will be 2,350. The division essentially divides the first variable by the second variable. If I type it in as shown into the row next to the division sign, you will see that the result will be 4.255319, and so on. And finally, there is a remainder sign, and the remainder sign is a percent sign, or it's called the modules sign, and it basically returns the modulus, or the mod, of the operator, meaning that it divides. For example, if I type in result, actually I should have put percent in the last row, so this is a mistake. This should have been a percent. So if I type in first percent second, the result will be 6, meaning that it will be the remainder of the division of first from the second variable. if you noticed, C does not support, including its branching programming languages such as C# and C++. They do not support the power operator. The reason for that is calculating the power operator, as the interpreting programming languages or the interpreters such as BASIC do, is time-consuming and is not efficient using in a compiler like a C-based compiler like C# or C++, because it's repetitive multiplication essentially, and it makes it inefficient in terms of defining within the program a power operator. To compensate for it, C# has a method or a function from a math object, and it's called math.pow, standing for power. And within the math.pow function, you put two variables, a and b, and the result will be essentially the first variable to the power of the second variable. So, for example, if you wanted to represent a to the power b, you could use it as result equals math.pow a comma b, and this essentially will raise number a to the power of number b. And this is essentially done to integrate more advanced operations and functions within the math libraries, and also to improve the efficiency of this operation. And finally, before we finish the arithmetic operators, I would like to talk about the priorities of these operators. If you were programming in Visual Basic, exponentiation or the power would be the highest priority, then it would be multiplications and divisions, and then it would be integer divisions, and then it would be the modulus arithmetic, and finally the addition and subtraction. But in C#, the priorities are essentially two levels of priorities. The first priorities are multiplications and divisions and modulus, and the second priority is plus and minus, or addition and subtraction. This means that if you have a arithmetic set of operations such as 2 plus 10 times 4 without any parentheses, the 10 and 4 will be multiplied first, and then the result will be added to value 2. If you wanted first to add 2 and 10, then you would have to force the priorities essentially by parenthesizing them, and anything that comes in parentheses takes the highest priority. So if we wanted to, in the equation that I just showed here, if we wanted to add 2 and 10 first and then multiply the result by 4, we would have to put 2 plus 10 into parentheses, and this way first the 2 and 10 will be added together, and then the result will be multiplied by 4. The other type of, or the third category of operators are essentially the comparison operators. And C# and Visual Basic and any other programming languages use these comparison operators to compare one value to another. And the result of these comparisons is essentially a Boolean value, which is false or true, or essentially you can think of it as 0 or 1. And a comparison operator always compares two values or expressions, and essentially you can't have more than one comparison with one comparison operator. One comparison operator performs one comparison between two expressions or two variables or two values, and or a variable and value. And the logical operators that I will talk about them later would use this combination factors to enhance the comparison operators. So the comparison operators are listed here. In C# I have the 5 categories of these comparison operators. The first category is the equality comparison, or the equality operator. It uses two equal signs, and you have to remember that you need to use two equal signs for equality comparison operator. If you use one equal sign, it will be an assignment, and if you put it in a comparison statement, it would return, you would get an error, or if you don't get an error, it would create a bug in your programs. So comparison operator for equal is essentially two equal signs, and the inequality operator is a exclamation mark and an equal sign. The greater than or less than operators essentially are greater than or less than signs, and if you put a equal sign next to them, they would become less than or equal and greater than or equal signs. And the checking operators, which is called is in C, checks if a variable is a certain type. So for example, if you want to know if a certain variable is an integer or a float variable, or is it a text box or a label, you could use the is operator, and it would return true or false depending on the type that you compared with. So for example, if I have put or defined first as an integer and made it equal 100, and a float variable called second equals 23.5, and a double result. So if I had added all those or performed all those arithmetic operations, then I could use the comparison operators to check to see what the result value is. So for example, if I say if result equal 5, that means that it is true if the result variable of the operations that I had previously done, if that value is 5, then the comparison returns true, or essentially evaluates to true, otherwise it evaluates to false. And result not equal 5 essentially is true if result is not 5, then I can have results smaller than or equal to 5, greater than or equal to 5. If I omit the plus the equal sign here and here, it would strictly return the value if it is only greater than 5 or only less than 5. So even if it is 5, it would evaluate to false. And for example, if I had defined my text box somewhere and I wanted to check if it is a text box, I could put if my text box is text box, and it evaluates to true if the text box type is defined as being a text box. C# allows you to concatenate two strings together and make a bigger string, and that variable is called that operator is called concatenation operator, and it is a plus sign in C#, and it's an ampersand sign in Visual Basic, but we're not talking about Visual Basic. So here's an example of using C# to create a statement by concatenating two strings. So I first define the string first equals hello, and string second equals world, and string result equals first plus second. The result will be hello world. And notice that I don't have any spaces here within the definition of or the declaration of the first string and the second string, hello and world. So the final resulting value for the hello world will be just one single line, one single word composed of hello and world together, and it won't have any space between them. If I wanted to add the space between them, I should either concatenate first with a blank space and then concatenate it with second, or I could concatenate or I could put a space before the W in word second, which is world, and it would create space. It would actually, the second variable, the second string, would have already a space in it. Now, an alternative way of adding or concatenating variables, basically what I showed you in this example on top, I use first plus second as concatenation, or I could first put result, I could first put first string into the result and then add result to the second and put it back to result, or I could use a simpler version of concatenation which C# supports, and that is result plus equal. And this sign plus equal essentially is equivalent to result equals result plus second. And you can just simply knock this down, knock the second result down, and then put the concatenation sign before the assignment sign. So it combines the concatenation and assignments in one single statement. This is also true for arithmetic operators. If you wanted to add a value to another value and assign it back to itself, you can use this this kind of annotation. So as I said, the comparison operators compare the results of compare two expressions and return a Boolean value, which is the truth of the comparison. To combine these operations or these expressions together and make more complex logical operations, we can use logical operators. And these operators are basically used to combine the results of multiple individual expressions and to make sure that multiple conditions are true or false. So the table that shows here, it shows the result, it shows different types of logical operators that C# supports. And let's start with the example. Let's assume that we have an integer variable called first, and it is 100, and we have a float variable called second, and it is 23.5. The first logical operator is an AND operator. It returns true if both expressions are true, and it evaluates to false otherwise. And it is represented by an ampersand in C#. So for example, the first equals 100, which is a comparison operator. It evaluates to true because first is 100. And notice that I have double equal signs for the comparison operator, not just the assignment. And then if I AND this with second equals 23.5, because that expression is also true, both of the expressions are true, therefore this evaluates to true. The OR operation, which is essentially a pipe, it evaluates to false if both operations are false, or if both expressions are false. The NOT operator essentially negates or reverses the Boolean value of an expression, and then the short circuit operations essentially short circuit the second condition if the first condition is not met. So let's assume that I have two variables, first and second, and the first variable is already not, or the first expression is not true, because the result of an AND operator will be false if the first operator is false. Then there's no need to check the result of the second expression, because the second expression, regardless of being true or false, won't change the result of the entire operation or the entire logical expression. Therefore, we can short circuit the second operation or the second comparison. Same is true for the OR. If you have an OR operation whose first value is true, regardless of whose first expression is true, regardless of the logic of the second expression being false or true, the entire expression evaluates to true. Therefore, there's no need to check that. And this would be useful and helpful when, for example, you have a condition in which the first operation or the first expression can be checked really quickly to see if it's false or true, but the second operation might take longer to check it to see if it's false or true. And also the fact that if the first expression is false, then there would be no need to perform the entire operation. It could simplify this process. For example, let's assume that we have a situation that we want to check if the username of the site user is administrator, and then to get the number of records from the database. So if the username is true, then we would like to check the number of the records in the database, see if they're greater than 0, and then perform an operation. Now, getting the number of records from the database would be a time-consuming task, and only we want to do that checkup if the users are admins. Otherwise, you wouldn't perform this operation at all. So this way, we can put the two conditions within the same shortcut expression, and only the system requires to log into the database and get the number of records from the database only if the username is admin. Otherwise, if the username is not admin, the expression evaluates to false, and therefore there would be no need to go on and log into the database. So as you notice, most of these statements that we showed here use a statement called if statement to demonstrate the logical operators. The if statement is a very important component of a programming language, and this is essentially the topic of our next series of slides relating to the decision-making processes and operations and statements within our programming language. So as I said earlier, the operators are useful because they would allow us manipulate and work with the data and the variables in our programming language, and here for our websites. Because we are programming for the internet and we are programming websites on the server. Another important component and another important set of statements that a programming language has to support is the decision-making statements. Because decision-making in an application is essentially very important and one of the most common things that we need to do as a developer. For example, we might need to hide a button from on a web server when the user is not allowed or should not be permitted to use this button. For example, if the user is not an administrator, we want to basically not allow them see the buttons that help delete some part or information from the website. Or we may need to display even rows in a table with a light background color and the odd rows with a more with a darker, for example, gray background color. All of these decisions are essentially made with a few different logic constructs or different logical decision-making statements called if else, and switch statements. The first and simplest of all decision-making statements is the if statement. The if statement contains two relevant parts, the condition that we are testing and the code that is going to be executed when the condition evaluates to true or when the condition is met. For example, if we want to make a button visible only when the user who's using the administrator is the website is an administrator, we can use a code like this: if user.isEnroll administrator, and this function evaluates to true if the user is admin, then we show the delete button visible as true, or we make the delete button visible or the visible property of the delete button equal true. This way only administrators will be able to, or will be allowed to see this delete button. And if the condition does not hold, then the rest of the code will be executed. If we want to run two mutually exclusive parts of code depending on the truth or the falsehood of a condition or a statement, we could use an if-else statement. In the if-else statement, if the condition is met, or if the condition or the statement evaluates to true, the statement that is in the if statement, then its relevant code will be run. Otherwise, which is when the statement is false, then the code that is written in the else block will be run. So for example, if I want to make sure that I will hide the button from everybody else except for the administrator, I use this piece of code here. So if user is enroll administrator, if that evaluates to true, then I make the divisible property of the delete button true. Otherwise, I put an else, and within the else block, I make the visible property of the delete button equals false. And this way, I make sure that the part of the code that has to be run when the condition is not met will be essentially run. If you have more than one mutually exclusive condition or statements, and you want to make sure that the statement or the pieces of code that you need to run under each of these mutually exclusive conditions will be run properly, you can use if-else statements. So, for example, let's say that we have 3 different roles and we want to have for the administrator to be able to see both the delete button and the create article, the managers to only be able to see the create article, and the members not to be allowed to see any of those buttons. We could use the if-else statements, and each of those condition codes will be placed within their relevant or respective block. So I check first the user role against the administrator using the user.isInRole function. These are just imaginary functions that I have written. So it would return true if the user is administrator. And then I put this statement in the, or this expression in the if statement. And if it's true, I make the visible property of both delete and create article buttons as true. Else, I check the role of the user as against the manager. So I put else if user is in role manager. So that evaluates to true if the user is in fact manager, and I put the relevant code within the block of else if. And finally, I could again use else if for checking if the person is a member of this website, and then make the visible property of both the delete and the create article buttons as false. As you see here, with using the else, we have using the else, the if-else statements, I check one condition, and if it's true, I run a piece of code. If it's not true, which is anything else or any other condition except for the condition that I'm checking, I run a piece of code. So that's if-else statements. Now, else-if statements would allow you within the else portion of your if-else statement to also check further more and more properties and more expressions. So these are a little bit more elaborate conditional statements than just if-else or simple if-else statements. The next set of statements are called the switch case statements. And switch case statements are essentially the statements that make the if-else statements, or the concatenation of else-if, else-if, else-if statements, more compact. So imagine that we're building a website for a concert hall, and during the week visitors can buy tickets online to go and see the concert on the weekend. And let's assume that we want to encourage the users or the visitors to buy tickets as early as possible. So we want to increase the discount rate for the users on Mondays, and then decrease it a little bit on Tuesdays, and for any other day we want to make the discount rate 0. And basically everybody would pay the full price. To do this, we need to first define the time of day and a discount rate as a variable, and then we check the time of day and against the date that we would like to give discounts, and then we would have several cases. The time of day or the day of week could be Monday, could be Tuesday, could be Wednesday, and so on. And we want to apply the discounts on Mondays and Tuesdays. So what you need to do is to create a switch statement, and within the switch statement you will put the time of day that you created. So the time of day here is today, and it's defined as a date time variable. So you have a date time type, and you define a today variable for it, which is the date time now, which is the current time of day. And then you look at the today and you see what day of week this today is, because a date time variable contains date, time, and a lot more information within which is relevant to the date type. So you're not interested in the time, but you're interested in the day of week. So you compare within the switch statement, compare today's variable as against the day of week. So this would return Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And this value, which is a day of week, will be evaluated within different cases. If it is Monday, then your discount rate is 0.4, and then you break. If it's Tuesday, then your discount rate is 0.3, and you break. And if it's anything else, which is the default discount rate, your discount rate is 0, and you break. There are two things that I need to make sure that everybody understands. First of all, the variable that you are comparing will go into the switch case, and the values you're comparing against will go to the case statements. So the variable that I'm comparing here is today. Of course, it's the day of week portion of it, and the values that I'm comparing it against are the day of week Monday, the day of week Tuesday, the day of week everything else. So that's the first thing that we need to understand. The second thing is the importance of putting this break after the statements for the case are finished. So I might have more statements. Here I had only one statement which says discount rate equals 4. Now I might have another statement that basically types in something on the web page, and then something else that sends an email to the person who purchased the ticket, and so on and so forth. So I could put all of those statements within the body of this case after the colon at the end of the case statement, but I need to put the break as the last line of that particular case, because if you eliminate this break, the statement would be compared against the Tuesday value, which is false, so this won't run, but then it goes to the default, and then it runs all of the code within the default case. So you need to make sure that you put the break, because what this break does is that when it runs all of the lines from the related case, it would break out of the switch and make sure that nothing else from this statement will be run. Okay, so we have studied the operators and operations that we can perform under 5 categories: assignment, arithmetic, comparison, and logical, and concatenation. And we studied about the statements that allow us to make decisions and control the flow of our program. Now what we can do here is that we can try it out and write a web-based calculator. In our calculator we will have a 2 text boxes that the users could input 2 numbers in, and then we would have a drop-down list that contains the list of arithmetic operators and arithmetic operations that the calculator performs, such as addition, subtraction, multiplications, and divisions. And then we can have a label to show the result of the operation. And to perform these operations, we need a button so the users would put the numbers in the text boxes and click the button, and this will perform the operations. So let's do that and try it in our Visual Web Developer and see how it works. Okay, so let's start our web-based web-based calculator, and see how we can program a C# code behind file for our calendar, and essentially create our first ever really programming application for a website application or a website. So in here I would essentially need to have 2 text boxes and a label for the result, 2 text boxes for the input values, a drop-down list for my operations, and a button for calculation. First, let's create a web form. I right-click on the website. I have already created a new website, and then I need to create and add a new item to it. So left-click on the new item, and then click on the web form, and then call it calculator.asp.x. Make sure that its Visual C# option for programming is selected. And if you are interested in Visual Basic, you can do that, and make sure that the system places the code in a separate file, which is our code behind file, and then click on add. So my first page is created. I will give it a title. I'll call it calculator, and I have the web form. So what I need to do is to bring 2 text boxes. So bring the first text box and call this text box value box 1, and it runs at server. And let's bring another text box and call it value box 2, and it runs at server. Between the 2 value boxes, I would like to add a drop-down list, So I'll add it between the two text boxes, and let's call this drop-down list calculator or operator list. Okay, at the bottom of this page I need to have a label that shows the calculation results. So drag and drop the label and call it results. And it runs its server, and the text for this label should be essentially label. Or we could clear the text property of this item, so it would be empty when we run the application. And finally, you need to have a button that would perform the calculations. So bring a button between the results and call it calculation button, and the text property, change it to calculate. If you go to the design view, you see that your design looks something like this, and I go back to the source view, and at the end here I put a return Now let's run the page. On the server. So here are the text boxes and the drop-down list, which is empty here, the second text box, and the calculate. And if you see, if I click on calculate, it posts back to the server, but it won't perform anything because the calculate button does not have any operations assigned to its clicked event. And that's what we need to do in terms of our programming. Okay, let's go back to the website and let's make a little bit of a little changes to this design of our file or our options and controls on our web server. So let's go to the design field and let's add to the drop-down list some items. Let's add the first item, and its value is called plus, and its text is plus, or essentially let's make the text just a sign plus. And then let's add another item, call it minus. Let's add another item, call it star for multiplication, and let's add another item. Let's make this one essentially plus also. And next add a division sample. So if you go back to your source, you will see that these samples are added and these values are added essentially to as list items to your lists. Now I need to make sure that my values are created properly, because I need to code against these. So I need to make sure that my items, list items, have values. And the division for the list item division. Okay, now if I run this code, it wants me to save it, and then let's go back to the website. So as you see, you have now the options of choosing between these values from your text box, but still you can't perform any operations here. Now let's write the codes that would allow us to get the values from the two text boxes when the calculate button is pressed, and compare these values and basically run the operations. One thing that we need to make sure that we actually have tested for running the test, the calculation, is to make sure that we have a value for the resulting function. Make sure that the text boxes are not empty, because if they're empty, then there's no code within those text boxes and you get an error. So first we need to make sure that we check if both text boxes are not empty. If they are not empty, then we need to create a variable called result to contain the result values to it. Convert the values of the two text boxes from text to a number, and then depending on the operations to perform the operations. If it's plus, add the values. If it's minus, subtract the values, and so forth. Now let's go back to the functions, and I need to create in the code behind file, which is a CS file, I need to go and create the button click event for the calculate button. If you double click on the button, Visual Web Developer would create this event for you. It's called calculation button click, and then you can type in your file, your program. So the first operations that we needed to do is to compare and actually check and see if both text boxes contain values in them. So the first operation is an if statement. The first statement is an if statement, and it wants to compare and see if the two text boxes contain values in them. The way to compare for this is to check the length of the text in the text box values. So the first box value was called value box1 dot. Its text option is in its text property, and then it has a length. So you want to compare the length of the text box and see if it is greater than 0, and also at the same time if value box 2's text box length is greater than 0. Notice that I used the operation, the shortcut operation, which is double ampersands, and the reason for this is if the first statement, which is the length of the text box of value box 1, is in fact equal to 0, it is empty, so there's no need to test for the second one, because already the statement is evaluating to false, and we should not run any code here. So I use this double ampersand, essentially the shortcut ampersand, that would bypass the second evaluation. So this saves a little bit of time. Now if checking for the second text box value was difficult, or you had to go on the database or log on the server and things like that, then you see that this will save time when eventually the result wouldn't change because the statement already evaluates to 0. Now, if both of these statements are true, meaning the text box 1 and text box 2 have values in them, then we need to create a variable, which is a double variable, and I will call this variable result, and I put number 0 in it, and that makes sure that it already has a value assigned to it. And then I need to create two variables that contain the numeric value from the text box values, and they should also both be double numbers. Now, the values within the text boxes are text. I need to change them, or they're strings. I need to change them from string to a double. Now, to do that, we could not cast these variables because strings are inherently different types than numerics. But we could use a function called convert, or a method called convert. So I would use convert method, and from the convert method, I would like to call its to double method, which essentially converts my variables from string to double, and the values are value box1 dot text. So this function would convert whatever is in value box 1 text properties into a double value. The same will apply to value 2, which is from converting to double the value of value box 2 text component, or the text of value box 2. So I have created these variables now. Now I have value 1, which contains or holds the numeric value from text box 1, and value 2 that contains the numeric value of text box 2, and they are essentially in doubles. Now, next operation is to compare the list item that comes from the operators list, and see if it's plus, then add the two values. If it's minus, then subtract them. If it's multiplication, then multiply them. And if it's division, then divide the two values. Okay. Now, I could use if else statements, or I could use switch statement, which makes this a lot more compact and a lot more easy to understand. So to do that, I would write the switch statement, and within the switch statement, I can add the variable, remember, the variable that I want to compare against several values. The variable that I'm comparing against is the selected value of the operator list. So I had an operator list that I created in my website, and this operator list essentially has a drop-down list, and it has several properties. One of those properties is selected value. Remember, when I put the selected already, IntelliSense would find the related properties that essentially have the same words in them. So I have selected items, selected items, selected index, and selected value. I could use any of these things. If I use selected index, then my plus would be 0 because it's the first component of this drop-down list, and so on and so forth. But I will use the selected value, which contains the value of those selected items, which was plus for addition, minus sign for subtraction, star sign for multiplication, and the / sign for the division. Now, because my switch case has more than one line in it, and that is true for any other statements such as if statements, if they contain more than one line, I would have to put them within these closing and opening brackets or curly braces. So the switch statements would go within this curly braces, and so I would have the first case. Remember, the cases are essentially the values that you are comparing your variable of the switch statement with, and so the first case is the plus sign. So if your drop-down list selected value is plus, then you want to make result equal value 1 plus value 2. And once you created this result, you need to make sure that you break out of this case, so anything else would not be performed, or any other part of this case statement would not be performed. So the next statement is when you're comparing your value against your variable against the value minus, which is within the case statement. And here you want to make result equal value 1 minus value 2. And again, you need to make sure that you break out of the case statements. Next, you need to compare your selected value from your operator list against the star option, and then if that is the star, then your result would be value 1 multiplied by value 2, and break out of the statement. And finally, you will have a case for /. Now, in this case, I could write result equal value 1 divided by value 2, and then break out of the case, and this will end my switch statement. Now if I do this and value 2 happens to be 0, then I would have a division by 0 case, which wouldn't be good. So what I could do is that I could make sure that the case I test or I check against value 2, and if it's not 0, then I would perform the operation. So in this case, I just simply add a if statement saying that if value 2 is not equal to 0, then perform this operation. And if it is equal to 0, then make result equal to 0, for example. So if you have a division by 0, then you essentially pre-fill the result value. Now that I have finished and I have done my my case, I need to put or my switch statements, so I have the value result according to whatever options I had for my arithmetic operation. I need to put it into the value of the text of the label. So I had a result label, which I think I called it result. If you don't remember it, you can simply go back to your calculator and go back to the source file and see what ID you gave it to the label, and I called it results here. So I need to go back to my code behind file and make sure that my results label box text is equal to the value of the result. But because it's a text string and the results is a double, I just simply convert the result to string by calling its toString property. Now here I have the entire code written if both text boxes were not empty. Now if one of the text boxes is empty, I need to make sure that I won't put anything into the results text. So I make the results text to be string.empty. Basically that would put an empty string within the results text. Okay, so here is essentially my entire calculator that I programmed, and as you see, it wasn't nearly as painful as it looks like programming for the web. So let's go back and let's run our web application, and here we are in the calculator. If I calculate against 0, there will be a postback with empty values from text box 1 and text box 2, and because that happened, the else statement here, so the if statement evaluates to false and the else statement evaluates to true, and an empty string will be put in the results text. Now if I put one value here and calculate, again the if statement is comparing both or checking both text boxes to see if both are not empty. So if at least one of them is empty, nothing would be present. Now if I put another number in the text box 2 and I press calculate, what happens is that because now both text boxes were not empty, results will become 0, value 1 will be converted to double, so value 1 will contain 1 and value 2 will contain 1 because both of these values are 1, and then I have the addition. So the switch statement is true for case of addition item, and the results will be essentially the addition of value 1 and value 2, and it would break out of the case, convert the results to a string, and then puts the results into my results text box, which is the label down here. Now if I choose the minus and I calculate it, the result will be 0. If I choose star and I calculate it, the results will be 1. Now let's have 4 and 3, and then if I click on / the results will be essentially a double value that is 4 divided by 3. And if I put 0 in the second value, the results will be 0 because the results did not get any value in it from the division, because I had an if statement here that says if the value 2 is not 0, make the division. If it is 0, just simply put 0 into the results. Now, another thing I could do is I could populate this result value with a value such as this, which would be a kind of an error value, and then I could compare this value into compare this value and when I'm writing the results in the label. So compare this minus 1111 and see if your results is not 1111. Then put the result value to string and then put it in the results text. Otherwise, make the results text essentially divided by 0. Okay, so let's just go over this division a little bit more. So let's say that if we divide by a value that's not 0, if value 2 is not 0, we just simply make the division, and the division is not likely to be minus 11111 value, and essentially when we're outside of the switch, we compare it with the error value that I gave it, and if it's not that error, meaning that the division happened, I put the results into a text and I put it into the labels text property. If the result, in fact, indeed is equal to this minus 111111, then I would basically run the else function, which tells me that I made a division by 0. So let's run this new code here, and let's make a division by 0. Let's have a 4 divided by a 2, and let's calculate the results, which happens. Let's divide it by 0, and if I calculate it, it automatically tells me that it was a division by 0 because I actually did in fact make that decision. Now if I go and I use a minus 11111 and divide it by 1, let me see, what was the value? Let's go back to the file. So if I actually make a calculation that happens to have the result that I had here, which is minus 1111, it won't be able to understand the difference, and it unfortunately makes this mistake. Now, to go about this problem, what I could do is I could add a new variable here and call this variable division by 0. So let's call a Boolean variable, and let's call it div by 0. Okay, and let's make this false by default. And then in here, if the value 2 was 0, in fact, I would make the div by 0 equal to true. And if it's not, I would make div by 0 equal to false in the if-else statement of my division. And in here, instead of comparing the imaginary result, I actually do in fact compare the div by 0 function. So if it is not div by 0, I write the correct result. If it is div by 0, the result has not been calculated correctly, and it would just tell me that it is a division by 0. Now if you run this calculator now. Now if I have a 44 and I divide it by 3, I actually do get a value if I divide it by 0, because I did calculate the division by 0, or essentially the second value was 0. Out here for value 2, it will not be performed, and therefore the div by 0 becomes true, and the else statement evaluates to true, and the result will be div by 0. Another very important component of your programming languages and statements is essentially loop statements. Loop statements are extremely useful in many applications because they let you basically execute a part of code repeatedly and iteratively without having to rewrite the code more than once. This is particularly useful when the number of the times that you want to run the iterations is not predetermined. For example, if you have a list of checkbox lists and you want to run a part of code for each of the checked selections or each of the checked boxes, you do not know prior to the running of the applications or the website how many checkboxes users would select. And of course, also in the case that even if you did know how many times you want to run the piece of code, rewriting the piece of code, for example, 20,000 times because you need to send 20,000 emails is impractical. So there are 3 different types of loops that C# and Internet programming would support. The for loop, the for each loop, and the while loop. For and while are familiar for most of you who have experience with the programming, and for each is a particular type of loop that I will discuss, and I will show you an example of that lets you run iteratively over several types of items and collections. So the for loop essentially simply repeats a code in a predetermined number of times, and you can exactly define the number of iterations that you want the loop to go through, and then it performs the actions. So the for loop contains 3 conditions within, or 3 statements within its definition. The first statement is the start condition. For example, int loop count equals 0. The second statement is the end condition, which tells you how many times you want to run this, and finally the loop count is the step definition part of your loop. So for example, let's say that you had a collection of or an array of items called roles, and it had 3 strings in it: first item, second item, and third item. You can create a for loop with a start condition of 0, and you want it to run for the length of your array list here, which is 3. So you make the loop run until loop count is smaller than roles.length, which is the length of the array, and you want the loop count increase 1 at a time, and then you add to the labels.text to the label1.text the value of the items and a return. So the result will be first item, second item, and third item on 3 separate lines. Notice that you can make the end condition more elaborate. It can contain a sophisticated logical expression that would let you run for a number of times, run the loop for a number of times. And the step definition could be basically anything. So you could either run and increase the loop count 1 at a time or 3 at a time. So you can make it actually have different step lengths in your for loop. The for each loop basically iterates over all of the items in a collection. So for example, in the roles, you could iterate for all of those roles within the collection. Or for example, if you have a text box list or a checkbox list, and you want to run a piece of code over for each of the selection or selected checkboxes, you could create a for each loop and then run the for each loop for all of the items within the, for example, the collection of checkbox lists. And the code will run within. So the simplification of the code previously we saw in terms of running over a array of strings and adding them to the end of a to the text of a label, you could run for each string in rows and add them into the link or the label. So because here roles variable is an array of strings, you can basically set up a loop with a string, essentially, that is this role value variable of type string, and then iterate over all those strings within the array. I will show you an example of this for each loop, so just to clarify and to see exactly how it works. The while loop is a special type of loop, and it essentially, the way as its name implies, it loops while a certain condition is true. So the other two loops essentially usually end by themselves, because you either run the loop for the number of iterations that you specified, or you reach the end of the collection and you already have gone over all the items within the collection. The while loop could potentially loop forever if the condition that it has to meet until it finishes the loop is over. So this requires an extra attention to be given to when you're designing the end condition of your while loop to avoid infinite loops. Another example, another way of avoiding infinite loops, if you are still not sure that your condition might happen to be essentially forcing the loop to run forever, is to create a predetermined number of steps that you will like to create and let the system run for that many statements or steps. If the condition didn't get satisfied, then essentially close the loop. So let me give you an example of a code that runs until it sends an email message. Let's say that we have created a function or a method called send email message, and it sends an email message, and it returns a value of false or true as having sent the email. So we create a Boolean variable called success. We make it false, and then we have a while loop that runs until success is not false, which is success is true, and it would run until it would basically try to send the email, and whenever the email is sent through send email message function, it would return a value true. It would make it into the success, and eventually the while loop will terminate. Now, if the email message has not been sent successfully, the condition cannot be basically evaluated, and we can't wait forever. Maybe the email is not a correct email address, so the email cannot be sent. So what we can do is that we can make a loop counter here and let the loop either works and run until success happens, or it is out of the number of tries that we, or the maximum number of tries that we can give it in as a loop count. So this code would run for 1,000 times. If it has been successful within that 1,000 steps, essentially the email message has been sent, the loop will be terminated. If the loop is not, if the message is not sent within 1,000 tries, then the loop count would reach 1,000, and this condition, loop count smaller than 1,000, would be met, and the loop will terminate. So it either sends the email or tries for 1,000 times, and it wouldn't send the email. And at the end of this loop, I can add a if condition statement, checking to see if loop count is 1,000, and then send a message that your email has not been sent successfully. You see, within this code, I can essentially have within this code the ability to tell the user that their email did not get sent because we tried 1,000 times, we couldn't send the email. Okay, I probably will not be able to talk about organizing code, and that would be the topic for the next week. But let me give you an example of running multiple operations on the calculator that we created, and I'll show you step by step how to do it and how to improve it. And then next week we optimize our code by organizing it, and I'll show you how to do that by using functions and methods. Then we talk about object-oriented programming and the paradigm of the object-oriented programming, and finally I will and then we will move on to more advanced web development and internet programming topics. So let's go to our Visual Web Developer and use loop statements to run a piece of code for several times to essentially run more than one operation. Okay, here I am at my website that I created. Let's run it one more time, and here it is. It's run. I can put two numbers in this code and press calculate, and this will let me choose between 4 different options to calculate the results. Now what if I wanted to put a number of operations here within a checkbox, and then let the user choose which operations they want to perform, and then click on a multi-operation button and see the results of all of their operations instantaneously. So what I will do is that I will add a checkbox list which will contain the checkboxes for plus, minus, and multiply, and then I'll add a button called multiple operation button, and then I'll add a label that will show the results of these operations. Okay, so first things first, I will go at the end of the results here in the design view and then press an enter. Basically, it would add a BR or a return at the end of my code there. So then let's go back to the design view, and then in here, let's add a checkbox list. And let's edit its items. Let's add an item called plus, and let's make its value plus. Let's add another item called minus, and let's make its value minus. And let's add another item called star, and let's make its value star. Okay. So I have my checkbox list. Let's go to the source view. As you see, it did not automatically make the values for the item because it detected that I was typing symbols instead of actual text, and it automatically eliminated them. So I need to make sure that I type them manually in the source code or the markup view. Now let's go back to the design view, and next to this text box, let me add a button Let's go to the source code. And here I add this button. I call it multi-ops, and I call the text of this calculate selected operations. Let's call the checkbox operations, and remember both of these are running at server. And finally, let's add at the end of this operation a label. Let's go to source view and eliminate the text for this, and let's call this multi-ops result. Multi-ops results. Okay, so I have the look of, or the design of my page, and here's how my page looks like. And if I click on calculate, nothing happens, of course. And these are my multi-operations. I can check any and all of them, and then click on calculate selected operations, and nothing will happen. And because the part of code that I already have for the calculate button is there, it calculates and it shows the result of the calculation in its label. Now it's time for me to start programming my label. I need to notice and point to you a couple of things. The name of the checkbox list is operations. The name of the button is multi-ops, and the name of the label is multi-ops results. So what I will do is that I will loop on the function, click function for the multi-ops button. What I will do is that I will again test and check to see if the two values are not empty. Then I create a result value and a result variable of double type, and value 1, value 2 variables of double type for each of the text box values. Then I will run for each of the items from the list, and for the ones that are selected, I will run a switch case statement to see which options are selected, and then I perform the corresponding operation, and I will add the result to the end of the label for multi-ops results. Okay, so that's what I will do. Now let's do that. Let's go to the design view and let's go double click on this calculate multiple operations. Now in the calculate multiple operations click function, when it happens, now first we need to compare and check to see if the value 1 text box, value 1 box dot text dot length is greater than 0, and value box 2 dot text dot length is also greater than 0. Okay, so I will run the multi-operation if there's text in the two values. If there's no text and I choose operations, it's irrelevant, so nothing should happen. Okay, now within here, now that I have the values defined, I need to create a variable for result and a variable for each of these values because they are text. After all, we need to change them to the to double. So I create exactly what I did, value 1, which is I have it up here. I can copy and paste them. I can convert the two values essentially to double. So text box 1 dot text converts to double for value 1 and converts to double for value 2. Okay, now if you remember from the previous option, like one operation click, I would just look to see which operation was selected, and then I will calculate the result and I will put the result to the results.text. Now here I may have multiple checkboxes selected, so what I need to do is to go over all of the items from the checkbox list. So the code for it is a for each code that I will run a block of code for each of the items within the text box. What I need to do is to create a list item variable I need to create a list item type. I will call it item. It's a list item type, and I want it to be from the multi-ops list of items. I probably don't remember the name of this list correctly. Let's go back to the source view, and it's called, oh, it was called the operations. So let's go back to the, so I want it to be the items within the operations dot items. Okay, so here we go. I want to loop over all of the operations items, put each of them in an item list variable called item, and then work a piece of code for that item. So now, when I do this, the first item that is being processed is the plus checkbox. So therefore, the item that will be checked now is going to be the plus checkbox. So I need to see if it is checked. So I would I would create an if statement, and I would run the piece of code for the plus sign and also for any other items within the checkbox if it is already checked or selected. So I would say if item dot selected, basically if the item is selected, which returns true if it is selected and false if it is not. And remember, the items are the items within the checkbox list, so there's a plus checkbox, minus checkbox, and multiply checkbox. So if it is selected, then I need to run my switch case. So I would compare the item value within the switch statements with three cases: case plus, case minus, case multiply. Now within each cases, I need to create a result. So the result will be value 1 plus value 2 for the first case, and I need to make sure that I break from the first case. For case 2, result will be value 1 minus value 2, and break it. And for case 3, result will be value 1 multiplied by value 2, and break it. Okay, now for each of these selected items that I have calculated the values, I need to add this value to the end of the multi-ops result label. So here, multi-ops results dot text will be added to the end of it a empty space plus result dot toString plus, because I'm writing in HTML, remember, the return at the end is a BR tag. So I add the BR tag to the end of it. So for each of the items that is selected, if it is selected, its value, it's actually should be value, its value will be compared with plus, minus, and multiply. The correct case will apply, and it would calculate the results, and it would change it into the string, and it would add it to the end of the multi-ops results label box. Okay, now my code is pretty much done, and I can run it. So let's save the code, and let us run the website. So here, if I click on calculate selected options, nothing will happen. Even if I select multiple of these options, nothing will happen because the two boxes are empty. Now let's have values for the two boxes, and if I click on the calculate, they would calculate, the calculate button will calculate the plus, the addition of 5 and 2, and it puts it in 7. If I calculate 1, it would basically click on plus here, checkbox next to the plus sign here, it calculates the option. If I click on minus and I select calculated operations, something interesting will happen, hopefully. Yes, and as you see, it added 7, which is the result of adding 5 and 2, and 3, which is the result of subtracting 2 from 5, to the end of the already existing results in the label. Now I'll give you a second to think about it. What happened here? Why did, when I clicked on calculate selected operations, why didn't it clear already the label for multiple operations text box? And why it added the results to the end, or concatenated the results to the end? It actually is a correct behavior. If you go to the code behind file, you will see that the multi-ops result label text will get added with the results of the selected operations every time we do this. The reason for this, that we will see that the previous results also happening, is the view state. If you click on multi-ops results and you click on the properties, and you go all the way down to the properties grid, you will see that the enabled view state of this label is by default true. Now, if you double click on the enabled view state property, it makes it false. If you go to the source code, you will see that by making the enable view state property false, which is here the tag enable view state equal false, your view state becomes disabled, and therefore it would not keep the result of the previous operations in. So again, let's have 5 and 2, and if you click on calculate, it would calculate the 7. If you click on plus sign here and click on calculate selected operations, it would calculate 5 plus 2, which is 7, and shows the result. If you press on minus, now you have plus and minus, and you press 7, press selected operations, it would run 7 and 3 as the result of adding and subtracting the two values, clears the label and puts the 7 and 3 back in. Now, interestingly, if I just click on star and I click on calculate results, it would actually calculate the results, clear everything, and puts it back. Now, notice one thing that is going to happen is that if I click on calculate option, calculate button up here, it would automatically eliminate the 10 because its view state is disabled. And now when I click on calculate, because this calculate uses a different code, it posts back to the server. The server clears all of the enabled view state, disabled view state values, which contains the label for multiple operations, and therefore it wouldn't show the result because it's not already in the calculate option. Okay, now if I click on everything and I click on calculate selected operations, it would perform the calculations for me. Now, it's kind of weird to look at this and see just the 7, 3, and 10 and not knowing what these are. What I could do is that I could go back to the code behind file here, and for each of these operations, while I'm creating the results, also I can pre-populate the text of the label for multiple operations with whatever operations were happening. So here I could go to multi-ops results.text equals value1 dot to string plus the plus sign value2 dot to string plus equals, and this way I will add essentially the value 1 converted to string, and then a plus sign, and then value 2 converted to string, and then equal sign, and when at the end I will add the multi-operation result here, you would see that this will essentially perform the actually show you the entire result in a mathematical equation. So let's try it. Now if I click on plus, and let's say that I have 4 and 7, and then I click calculate, it would say 4 plus 7 equals 11. If I click on minus, it wouldn't say the same thing for the minus. What I could do is that I could copy these values here, or this line here, and paste it for and for this option I will put minus, and for this option I would put star. Now if I run this code and I add the values to this and I click on plus, it shows 6 plus 3 equals 9. 6 plus 3, I made a mistake somewhere. Oh, concatenating this to the value. So yes, you need to concatenate these values to the already existing label. Okay, so again 5 and 7. So if you click on plus, 5 plus 7 is 12. If you click on minus also, now you get 5 plus 7 equals 12, 5 minus 7 equals minus 2, and now you have all these values. So you could have any and all. And since we are going over each items within the list from the beginning of the items to the end, the order is always from plus to star, which is the order we put in our text box list. But the ones that are not selected, as you see, the operations will not be performed on them, and that is the result of this if function. So if the item is not selected, then the entire operation would not be performed for it. Okay, so I hope that this was a useful class, and that we learned a lot about programming with C# and the components of the programs we have, and now we can start basic web programming using C# and ASP.NET. And I close this lecture here, and next week we pick up on the lecture about organizing our code and object-oriented paradigm and what it is. And I hope that you prepare yourself for the midterm, and the midterm is going to be posted during the times that it will be active, and you can go on Blackboard and take the test. And the test will have multiple choice questions, true-false questions, essay questions, essentially short program questions, and it is about 2 hours long. So there is enough questions in the exam to keep you busy for the entire 2 hour. Okay, so I will finish the lecture for tonight and this week, and I will speak with you next week. Thank you. Bye.